Okay, so this is our next example, example number 2. Now, for this example, you'll notice I'm now using a VT graph. So I can do all sorts of stuff with the VT graph. I can find the slope, which is going to be the acceleration, and I also can find the area under the graph, which is going to be my displacement. Now, in this first one, it's asking the instantaneous acceleration, which is the exact acceleration at 1 second. So I'm going to see where 1 second is, and there it is, kind of in the middle of the line. So that means I can find the slope of anything on this line. I'm going to use other points. I'm going to use 0, 0, and I'm going to use this one because it's at 12 and a half, halfway between 15 and 10, and 2 and a half. Maybe slightly awkward numbers, but I know they're exact. So there's no estimation, so it's still better than nothing. So I'm going to say I've got 12.5 minus 0, because that is my my rise. And then I've got 2.5 and 0. Now remember, the point here is I am finding my slope, because my slope is going to be my acceleration. So that is what I'm trying to do. So there we go. So 12 and a half divided by 2.5 gives me 5. That means I have a slope of 5. Now remember, this is acceleration, right? We're finding acceleration. So I'm getting 5, and I can say 5.0 because I have the sig figs, and it's going to be, in this case, meters per squared. The squared is very important, right? The squared is telling me it's acceleration. The acceleration units are really important. Okay, awesome. So I have my first part done. Second one, average acceleration. Again, we're going to use slope. We're going to join our first point, in this case, to our last point. And we're going to do that because I want to find the average acceleration, just like we did in uniform motion the other day. If we tried to figure this out separately, I would have to figure out this slope and the percentage it's at that slope, this one, percentage, that one. I'd have to do it as proportions. Yuck, don't want to do that. Ick. I can do this really quickly, right? I can figure out the slope very quickly. So I'm going to do that. I'm going to find my slope by just joining those points. And all I have to do is find two good ones. And again, 0, 0 is an awesome point, so I'm going to use it. And the last one is really great at this one as well. It's 30 and 10. What an easy number. So that's what I'm going to use. Make life easy. Don't pick difficult points where you have to estimate. Pick points that are easy. So 30 minus 0, and then over, in this case, 10 minus 0. I don't even have to think hard for the math, right? No calculator necessary. I know that is going to be 3. Now I'm going to say that it is 3.0 because I want to maintain my 2 sig figs, and it's meters per second squared, because we are still dealing with acceleration, right? So that is what we need to do. So we're good. Don't forget my line so it makes sense. Okay, so our third one. How far does the car travel in the first 4 seconds? Actually, I'm going to do this as a separate video so I don't run out of time.